In the past, we have used the graph of a unit circle to define our values of the trig functions. Today we're going to look at actually graphing the trig functions themselves. So instead of looking at a graph to try to determine the definitions, we're going to actually graph the functions themselves as functions of real numbers. We'll start off looking at the sine function, y equals sine x. We know that if x is 0, then sine of 0 is 0, and that gives us the point 0, 0. We know that at pi over 6, our sine value is 1/2, because sine of pi over 6 is 1/2, and that gives us a point pi over 6, comma 1/2. And as we continue, we get pi over 2 gives us a 1, 5 pi over 6 gives us a 1/2, and we see this pattern moving up and down in what we call a sinusoidal wave. Notice that for the sine function, our y-intercept is at y equals 0, and our x-intercept is going to happen at multiples of pi. Now here are some properties of the sine wave. The domain is all real numbers. We discussed that last time. The range is going to be all real numbers from -1 to 1. In other words, the y values. And this is inclusive, meaning it does get up to the 1, it does get down to the -1. The sine function is an odd function, meaning negating the input would negate the output. So negative pi over 2 goes to -1. Graphically, what this means is that it is symmetric with respect to the origin. Any point on one side of the graph, on one side of the origin, has a twin point, opposite direction, equidistant on the graph as well. The sine function is periodic with period of 2 pi. And we remember that from the unit circle as well, because each time you do a full circle, you're back to a value, a y value in this case, that you've been to before. So from here, if we go 2 pi further, we're at that same y value. Or from here, if we go 2 pi further, we're at that same y value. The x-intercepts, as I said a moment ago, are going to be all your multiples of pi. Your y-intercept is 0. And your maximum value is 1, and that'll be at pi over 2 and any multiple of 2 pi above or below that. So pi over 2 plus 2k pi, or k2 pi. That just says any multiple of 2 pi above or below that. The minimum value is -1 down here, and that's going to be at 3 pi over 2 plus 2k pi. Now let's look at the cosine function. The function itself looks very similar, and in fact it is the same values in the same order. It's just shifted over a little bit. If x is 0, then cosine of 0 is 1, and it gives us the point 0, 1. Pi over 3, cosine of pi over 3 is 1/2, so that gives us pi over 3, comma 1/2. Whereas the sine wave starts at 0, moving up, cosine starts at the top, moving down, goes all the way to the bottom, and then comes back up. On a longer graph showing us the full periods, we see that, once again, the domain is the set of all real numbers, which makes sense because I said sine and cosine are very closely related. The range consists of all the real numbers from -1 to 1. Now cosine is an even function, and it's symmetric with respect to the y-axis, meaning for any point on the right side of the graph, there is a twin to it, equidistant, straight across on the left side of the graph. This is with respect to the y-axis, meaning the y-axis is basically acting as a mirror. It's periodic, the period is 2 pi, and the x-intercepts now, instead of being the multiples of pi, the x-intercepts are pi over 2 plus or minus some multiple of pi. So if we go up at 1 pi, go up another pi, go up another pi, go down a pi, go down another pi, that's when we're going to end up on the x-axis. The minimum values are going to be at the odd multiples of pi, -1, 1, 3, 5, 7, and the maximum values are going to be at the even multiples of pi, -2, 0, 2 pi, 4 pi, and so forth.